had quite a few of those simulations related to PPG. In the Interactive Spectrogram Generator, you can actually select the PPG or any other signal type, EMG, ECG, EEG, EOG as well. You can change your time window, your amplitude. This one is obviously more chaotic, well, because if you assume you have free will or not, it's your brain or whatever else is deciding how much eye movement you make, as opposed to something like ECG, where if you reduce the noise, increase the amplitude, you have a variability in the QRS detection, which will indicate all sorts of heart conditions. The heart rate per second, so it's looking at 5 seconds there. Currently the heart rate is whatever, 70, 74. That's something less chaotic, unless you have an arrhythmia, then it's becoming more chaotic. So yeah, we do have on the side, if you select the ECG, we have this ECG simulator that actually does monitor all that. Not monitor, it allows you to generate synthetic signals that will take, simulate sinus bradycardia. So look at the timing of the signal. You have your PR, QRS, QT, ST timing, so you can adjust them manually. If you do normal waveform, reduce the noise and change your PR interval. It's PR is the distance between that point and this point. When you change it, it's becoming smaller, so the P peak is closer to the R peak. When you increase it, it becomes further away. Same for QRS. It's the whole shape, the width of the actual main spike. The R peak being the middle of it, so you can make it slower or faster. QT is that T wave is the last wave in ECG QRS P QRS T complex. So that last QT, you can make it further or closer to the R peak. And ST offset is that beat that you have immediately, that downward dip that you have immediately after the QRS, so after the S, and you can control its offset as well. So when you select a different preset, what it does is, looking at literature, it will change all the settings accordingly. So if you select ventricular tachycardia, it will do this, where the QRS is set to high, the PR is low, QT is low, offset is 0. And then you can play around with it yourself to make it look like more matching what you are sitting on your ECG machine. So go check out this tool as well. It's quite comprehensive. Anyhow, as you can tell, there's a human in the loop, meant to be an expert. My expertise is actually around EEG and hearing, cochlear implants. We obviously have cochlear implant simulators. When you can pan the whole thing, you can use the robot insertion of the electrode arrays, move the electrode array manually yourself, pretending to be a surgeon. Works pretty well, showing you depth of insertion, the forces. So if you here, there will be an indication if it's safe or not. So if you're going too hard on the tissue, you'll be doing damage. And we also have the speed of insertion, which really hard to control manually. However, if you use the robot, it will just get inserted at a fixed force, fixed speed, constant speed, and just the depth is changing as the electrode array is being inserted automatically for you. So you can just watch, sit back and relax as a surgeon. You don't need to do anything. And you can tell your parents, when using this tool, you can tell your parents, hey, because obviously they always wanted you to be a surgeon. You can tell them, I actually am, because I use this tool. If you use this tool and record a video of how you used it and publish it on YouTube, you also get a certificate from BioniChaos, something that is highly sought after piece of digital paper that you can add to your CV. But let me know if you have any questions about any of the content on bionichaos.com. Yeah, go check this one as well. This is essentially a table of different modality recordings, but it's essentially comparing spatial and temporal resolution of different sensors that you use for determining your health, medical state. And it will tell you the sampling rate, the cost estimation, ballpark. Well, not ballpark, so it's a normalized estimation, and normalized temporal and spatial resolution of the recording. So you can see it on the bubble chart as well. Hover over, see the details. So you have transcranial magnetic simulation, you have 4K video, ultrasound, EMG, so on and so forth. Yeah, go check it out. Don't forget to like, subscribe, unsubscribe, whatever you need to do. Robots, humans are welcome to join in. Those live streams meant to be interactive. This is happening in real time. Oh, we have the second version of the pendulum draw. What do you think this will sound like? Hey, this is new. It's new in the sense that we also have audio for it. Might be annoying. How do you like that? This is just the audio for the third pendulum. So it's, yeah, well, because the first pendulum we're just doing, yeah, just doing something simple. Second pendulum, slightly more complicated. And the third should be, let's change the angle for it slightly. Let's damp, or not. Let's shorten, let's pop it in a different color and do. Let's damp that one a bit, and let's make that one. Okay, so they're moving. Sometimes they can move in a chaotic structure, and sometimes there's actually order to the chaos. So that one's actually doing quite a sophisticated pattern there. Let's put it in black for a sec. Yeah, so it's the black, the sound is coming from the black pendulum. Let's change the angle for it. Yeah, so it's the red one at the moment. Would you use it as a musical instrument? Would you count this as music and the canvas as art? Or do we need to add a fourth pendulum? What do you think? What do you think?